So the title of my talk is how to promote a small segment within an existing big recommendation system. It's not the most compelling title for a talk, but it's quite descriptive. A little bit about me. I've been around in the industry for about 13 years, different domains. The last 2 years, I'm a data science manager at Agoda. I'm responsible for the small local site that we have here in Tel Aviv. This is my LinkedIn address. Feel free to connect and give feedback after the talk. I really like to hike in the desert, especially when I was young and fit. The agenda for today, so it's not a very technical talk, but I think the use case is interesting. Having a small segment that we want to promote, so we first define the problem, and then just describe like 2 or 3 things that we tried and what worked for us and what didn't. So a little bit about Agoda before we start. So it was founded in 2005. It's a big online travel agency. So it's part of the Booking Holdings group. Other companies in the group are Booking.com, Kayak, Priceline, rental cars, many other companies that maybe you didn't know that are affiliated. And Agoda's special focuses in Southeast Asia and Oceania. So these are the core markets of Agoda. The headquarters are in Bangkok. We are a group of about 42 data scientists, and here in Tel Aviv we're about 9 and growing. And in travel tech, there is ML all over the place. When you surf the website, you get like, I don't know, dozens of models running in the background, making all kinds of decisions of what you see. The prices you see, the hotels you see, and so on. So this page is the search page. You're familiar with it either from Agoda. Has everyone used Agoda before as a user? Yes. Okay.
The booking group.
Yeah, the booking group, definitely. So it looks rather similar, right? You input a destination, a date range, a few other specification. You have some filters, and you get a list of hotels. So this is powered by our recommendation engine, right? It tries to show the most relevant hotels to the user. And we have a very optimized RNN model that runs and tries to take into account both the user context and the hotel properties and the search queries and so on. And there are a lot of business rules on top, as sometimes recommendation engines have, and product people like to add on top of our beautiful machine learning models. And I won't touch about this core engine. I'm gonna describe how we interact with it. It is optimized in an offline metric of relevancy, but it's tested on our business metric, which I'll describe in a moment. This is the segment that we're trying to promote. It's called NHA, non-hotel accommodation. It's kind of an annoying name. For the first time I saw it, why is it non-hotel? Why does not call it like homes or apartments or something like that? The reason is that it's a huge spectrum. So you get all kinds of properties under NHA. So starting from bungalows on the beach, villas, minsu, which is destination specific. This is a guest house in Korea or in Japan, and also serviced apartments. So serviced apartments are almost like hotels. Some of them it's like a building of apartments that are cleaned every day. Sometimes you have reception, but it's not like an hotel. It's for longer stays and so on. So it's really a continuum of different type of properties. So this is why I surrendered my resistance and started using NHA. And why is it an interesting segment? First, let's talk about the effect of COVID. So COVID was like a huge catastrophe, right? Once in a lifetime thing, especially for the tourist industry. So what you see on the left is it's the decline of demand of users booking in Europe. So it was like minus 90% of the business in 1 month in 2020. And what you see on the right is this is Agoda numbers. So you see the drop. This is for NHA properties, different types of NHA, multi-room, single room, and hotel-like. We divide them into these 3 categories. So you see the drop here, but what you see is the red line here that the relative part of homes and hotels actually grew. So it fell, but less than 90%. Okay, so the fall was not as drastic, and the recovery was faster for hotels and for apartments and homes. If you remember, people didn't want to be with other people. You prefer to book a small home in a remote place. So this is like one thing that helped to boost the segment. And another thing is people started preferring longer and longer stays, right? Remote work became very popular. We all wanted to get away from quarantines that was closing in on us. And this is like the dream, right? Writing from your laptop in some kind of a tropical island. And in Airbnb, these are the share of properties that started taking like 2 weeks minimum stays. And the reason they did it is because people actually were willing to book for longer periods. So this definitely increased. Also, this is not related to COVID. People started looking for more special experiences that sometimes hotels could not provide. By the way, one of these pictures is fake. Who thinks the shoe picture is fake? Okay, who thinks the pumpkin picture is fake? Okay, not everyone vote, but you're right. The pumpkin house is fake. I created it a couple of days ago with a stable diffusion model, a pumpkin house in the forest, something like that. But it's not the same resolution. It's not a fair comparison. So looking for a unique experience is also very important. Let's talk a little bit about the challenges. So first, in Agoda, we have a shared feed. So unlike Airbnb, when you go to Airbnb, you usually your intent is clear. You want to book an apartment or a house, right? In Agoda, it's not so clear because we accommodate for different type of properties, both hotels and homes, and for a different mix of users with different intents. Some of them are looking for hotels, but might be open to change their mind if they see a good price for an apartment in the city. Maybe they switch for an apartment. So the mixed intent users makes it, and the mixed feed makes it more challenging. The other problem is that homes are long tail by definition, right? They don't get a lot of traffic like hotels. It's very sparse. You get like one booking a month, or for some properties even less. And our ranking model was optimized for many years for hotels with a lot of traffic. And it's a really painful long-term problem. Like, I guess there are analogies in many other business use cases from your domains. Another thing is that there is less content. People write less reviews. There are less pictures of the property, less data to work with. So that's for the long tail. And what makes things more difficult is that the cold start problem is even more evident. People could Google for, I don't know, Hilton Tel Aviv, but no one would look for Yair apartments. I did. There is a place in Jerusalem called Yair Apartments, but usually people don't search for these properties directly, right? So getting this first one or two first bookings is very difficult, and our ranking engine is really, looking forward to properties that, got their first boost. Someone was interested, there was a transaction, and so on. So the cold start problem is very, very difficult for homes. And another thing is it's a different world. For example, when you book an hotel, usually the booking is instant. You get a confirmation to your email in a minute. In homes, it's not the same. Sometimes the owner would like to approve you, would like to see your rating or whatever. So it's not an instant transaction. So this is what we call book on request. Another different features, for example, superhost. So Airbnb has it, for example, if the owner is very responsive and polite and so on, then he gets this superhost badge, which is something that we don't have for hotels. So there's a lot of features or domain knowledge that is specific for homes that is not formulated for the general ranking engine. Or even if it is formulated, the chance that it would pick this very sparse feature that is relevant for such a small part of the data is very small. These are the challenges. I would just like to add a new term, the second one after NHA. This is how Agoda defines value. That's the definition of money in Agoda. It's called LTC, or lifetime contribution. Basically, there are three main components. The margin prediction, which is the revenue that you get. But it's important to note that even if someone makes a booking, it doesn't mean that the booking is going to happen, right? Most of bookings today are with free cancellation, and some of them do get canceled. So we have cancellation rate prediction models that tries to accommodate for that, and we try to take that into account. But this is the main part of the revenue. The second part is what we call DLTV. So LTV is lifetime value, right? What are the chances that if you visited the Agoda website, you will come back next year and make another booking? So this is, and the delta part of it is like how much we expect the lifetime value to change given the current booking, okay? So it might be useful even to lose in this current transaction if we believe that you will come back next year and be profitable for us, okay? So this is like the future contribution, another model-based component. And the VC part is what we call the variable cost. It's basically the overhead cost for customer support and so on and so forth. So this is the definition of value that we try to optimize. And let's define the problem. So now we want to optimize this LTC. We have a budget to spend. We want to maximize the NHA LTC, right? We want to get the value from homes, but we want to do it such that we still maintain some efficiency. So how we define efficiency? The boost in NHA LTC, the NHA lift, divided by the opportunity cost that we lose. Because if we take traffic from hotels and move it to homes, we are also losing money, right? So let's say in an ideal example, this ratio is 1-to-1. So for every dollar that we move from hotels, we get $1 in NHA. That's great. We can, be very flexible in our business. But usually we don't get this efficiency. So let's say if it's a efficiency of 1-to-10, we need to spend $10 to get $1 in NHA. It's also very poor, right? So I will talk about how we measure this stuff. But this is what we call efficiency. And the next part, now we've defined the problem. The next part would be to describe different approaches of how, given this framework, we try to tackle this problem. The first approach was to create some kind of a personalization for NHA. We call it the intent model. Basically, what the intent model does, it tries to identify NHA-related users, or more precisely, sessions which have high chance of converting to homes rather than a hotel. So this is basically a classifier that tries to estimate that given the chance that there will be a booking, it will be an NHA booking, okay? So the likelihood of the user in this session to book a home rather than a hotel. And the model features are basically three different categories. Geography, which is very important for us because we don't have the same inventory in Los Angeles and Tokyo, for example. We don't have the same amount of homes to offer. The user history, clicks, like how many bookings he has from previous, how many NHA he booked in the past, and so on. And the context of the search query, like how many people are in the search query, how many adults, children, length of stay, and so on. And just to see from the SHAP value distribution that a lot of the features make sense. So for example, if people are looking for many adults, there is a higher chance, that's the red color here, there's a higher chance that you'll be interested in homes. Okay, so if you book for 5 adults, good chance that you're booking for a home. If you clicked on many NHA properties during the session, there's a high chance that you will be booking an NHA, right? That makes sense. So, the features are behaving well. And another thing that was very encouraging to us is when we measure the conversion rate of the different intent scores. So on the x-axis, what you see here is the prediction of the model. And you have 4 bars here. So the grayish one is hotels. And the other 3 are different NHA types, single room, multi-room, and hotel-like. And first you see that all of the NHA ones are monotonically increasing. So higher intent means higher conversion rate. That's one good sign. And the other thing is that hotels is not increasing. It's even slightly decreasing. So that means that the model is differentiating between hotel bookers and NHA bookers. It's not just identifying bookers, right? This is what we want. Okay, so how does so now we have this cool model. What can we do with them? So a lot of nice stuff. One of the things that we've tried initially is to create injections. So basically, the flow was as follows. In the beginning of the session, the intent model gave its prediction. We assigned it to one of 5 buckets according to quantiles, and each bucket got its own injection slot, and we would put NHA properties artificially. We would bump them according to their initial ordering of the ranking model, but we would just increase the rank according to the NHA, to the intent model prediction. Okay? And if you would get, so what you see here is the injection slots that were initially hard-coded for each one of the 5 groups. So if you're in group 5, you have the highest intent, you will start seeing NHA properties on a very high rank. In the top 10, you will get like 3 NHA properties to begin with. So this is how we started using it. So we injected the properties. And this proved to be quite rigid. We started to think how to optimize it. So the first thing that we did is to separate according to device, because the number of properties you see in your laptop, on your big screen monitor, it's like, I don't know, 10 or 15, and what you see in your mobile has, I don't know, top 5. So it doesn't make sense to have the same injection policy for both displays, right? So we started having injection configurations for both desktop and mobile, and started to complicate and thinking how to optimize it. But then eventually we switched, and we started giving a more continuous boost. So instead of just using fixed injection slots, what we did is to take the initial ranking score, which is distributed something like this, maybe log normal, and just add a bonus according to the intent. So this is what you see in the graph here is the prediction of the intent model, and this is the bonus, like how many points it got from the intent, and the blue line is this function, how much bonus we give. There's a reason why it's like linear and in different slopes, but what you see here is the distribution of users. So you see that very few users reach the high prediction rates, right? So most of the users are very low intent, and they should not see a lot of properties. What are the benefits of this approach? So first, there's more granularity. Instead of having just 5 groups, you get like a continuum according to the prediction. It's much simpler to engineer, right? You don't have to keep a lot of configuration. It's just it's a very simple thing to code, and it allows the controlling the ranking bonus with very few parameters. So if this is a function, you can define it by, I don't know, 3 or 4 different parameters that you can optimize and get a very significant impact on your business segment. And it independently of the ranking engine. And it relies more on the intent and the ranking engine than having like this fixed injection slots and configurations that maybe we tried a year ago, but we are not continuously validating if these are optimal. So this is why we switched to continuous boosting instead of injections. And now the question remains is how do we measure efficiency? Like how do you know what is the increased lift and how much it costs us? So the answer is similar to what Tabula showed. So basically we do a holdout experiment. Here the B side, the treatment is the holdout. These are users that don't get boosted at all. So they just see the the ranking engine's results without any bias. And then we measure how much the different, you see that the hotels get more bookings, and the NHA multi-room and single room get significantly less bookings because we remove the boosting. And we also know that the cost, according to the A/B test, we know how much money we are losing with this holdout experiment. So this is like our monitor, and this is very nice for senior leadership because now they can put a cost on what we do, like how much money we're willing to spend to grow the segment, and we also know the benefit, like how much we are gaining by spending this money, and this could be like further applied to different engines or channels within the company, not just ranking. It could be in marketing or pricing or other internal units that we have could use the same mechanism. The second thing that we tried, we thought maybe the data is so sparse and so long tail, and the ranking model is so unoptimized for NHA properties that we could do better. Let's try to build NHA-specific model on top of the ranking engine, and it would basically be sequential. So let the ranking engine give its list of properties. Some of them would be hotels, some of them would be NHA properties, and then let's re-rank them. Let's reshuffle only the NHA properties. We are not touching hotels. We don't know anything about it. We're trying to create a better ordering for NHA, and we will have a dedicated model with a dedicated data set and features that maybe would perform better. So we tried that. We built a light GBM model with lambda rank loss function, and we did the learning in pairs. And then we just applied it on the top K NHA properties, got a point-wise ranking score for each one of them, and just resorted them again, okay? One interesting thing that we had to be aware of, almost went live with it, is that we added latency, right? This is also always important in recommendation systems. You could do something very nice offline, get very nice results, then you launch an online experiment and everything crashes because you added like 50 milliseconds to the loading page of and the user just bounced. So we had to work very hard to make the predictions parallel and not to add latency and so on, or little latency. This is a very important part of the process. But the result of this was not good. I mean, we spent a lot of money and we didn't boost NHA as we have hoped. And now we need to, this is like work in progress, now we need to understand whether we had another bug or performance issue that we didn't understand. Maybe the model was not good enough, or we just need to ditch this approach. The next big thing that we're going to try, and maybe you would argue that this is the first thing that we should have tried, or the simplest thing. Why not just tweak the weights of the model and give NHA bookings, for example, more weight? Let's say that a dollar from NHA is now worth, I don't know, 50% more than hotels, and just let the ranking engine do its magic. Just bias the model in that direction. This is something that sounds very easy to do, but it's not quite easy because of two main things. First, we don't know how much we should bias it. It's hard for us to do it. And the second thing is, when we change the value of something in Agoda, we change it company-wide. We can't change it just for ranking. It would also take into effect in, I don't know, our marketing spend in Google. So now we will start biasing everything on traffic from Google, for example. So it's very hard to, when you change this value, to contain it only for ranking. So this is like a technical thing that prevented us from trying it, but we will do it soon. And another thing that is interesting, and with the intent score that I've mentioned, we can combine it, for example, with marketing. So for example, if someone came to our website after he Googled apartments in Tel Aviv, and he just landed in the Agoda website, so his NHA intent should be high, right? Because its keyword in Google was very high, so we want to preserve this. So we want to integrate the intent as up as we can in the funnel, in the user funnel. This is one thing that we are looking at. And another thing, the intent model is, and maybe I will summarize with that. So the adding a segment-specific personalization model is a very nice way to gain volume while maintaining efficiency. And it's a very flexible tool because it could help with the cold start problem. For example, I've mentioned giving these first bookings to new apartments. We want to show these new assets to people who have already high intent, right? We don't want to show them to people who are looking for the Hiltons and Marriott of the world, who are not really interested in apartments. So it helps us tackle the cold start problem, and you can use it in a bunch of things. For example, you saw the filters on the search page. Why not show custom filters for high NHA intent users? For example, a filter, show me only homes if you are a high intent user. So it's a flexible thing that you can use in the entire session other than just the ranking feed. I hope this point is clear. Another lesson learned is that latency and user experience is very important outside of the offline optimization, and stable diffusion images are very cool. This is another one from Stable Diffusion. I just want to wrap up and open up for questions, but I want to thank the two data scientists that work on it. So Chaim was the first one, started a year ago. And now Omri is leading it. Now he's in Bangkok working very hard from our headquarters, as you can see. Both of them led this project, so I want to thank them. And I think that's it.